Hi everyone, I'm Kalawa. This is Made Simple with us. Don't forget to subscribe to our channel and always hit the notification button so whenever we upload video like this, you'll be the first to know. So today, we are going to discuss on how we can solve simultaneous equation using matrices. This is a slide I have prepared. It is simple. It simplifies everything you need to know about solving simultaneous equation using matrices. Using matrices to solve simultaneous equation involves representing the system of equation in matrix form and then using matrix operation to find the solution. This method is particularly useful for system of linear equation. Take note, it is useful for system of linear equation. There are two methods involved in solving simultaneous equation using matrices. One of the methods is the determinants method, which we sometimes call the Cramer's rule. And the other method is the inverse method. I bet you most of you surprised to see the second method. Well, this is Made Simple with us, and we are here to simplify everything. So the second method is the inverse method. So let's start with the first method. The first method, which is the determinant method, or we sometimes call the Cramer's rule. The Cramer's rule is a method to solve a system of linear equation using determinants. It is applicable when the system has as many equations as unknown. That means when we have many unknown in a linear equation. And the determinant of the coefficient matrix is non-zero. Here is a step-by-step explanation. Now, in solving simultaneous equation using matrices, that is using this first method, which is known as the Cramer's rule, or we say determinant, there are steps that you must follow. But in this case, I'm going to take example so that you guys can see how it works. So step one is saying we represent the system in matrix form. Now consider a system of linear equation. This is the system of linear equation. Let's consider this equation. That is this whole aspect. Let's consider this whole aspect as the equation. So let me just take, and we have work problem also. Let's say we have 5x minus 3y is equals to 28. And then we have minus 2x plus 4y is equals to 13. So I'll be solving this example and also follow the step. So now we are to represent this system in a matrix form. Remember, this is the system, and they are giving us this linear equation. And this is the example. So if we are given this example and then we are asked to solve this simultaneous equation using the Cramer's rule, the first step is saying that we must represent them in matrix form, meaning we must put them in matrix form. So for this first aspect, we are going to take the coefficient of the variable. So the variable here, there are x, y, x, y. So we are going to take the coefficient and put them in one form, and then we take the variable in another form, and then we take the constant in another form. So let me do this again for this example. For this one, the coefficient of x, they are 5 minus 2 minus 3, and then we have 4. So this first set, we call the first step to be the A matrix. Now, the second step is, after we have taken the coefficients out, the second step is saying, the second aspect is saying that we take now the variable that we call this variable now to be the X matrix. That is going to be X and Y. We have two variables there, that is X and Y. So we put it in another form, and then we also take for the B matrix. The B matrix, it is also called the constant matrix. The B matrix is also called the constant matrix, and then for the constants here we have 28 and then 14. So you are going to put this equation in this matrix form. That's the first step. The second step now is saying we compute the determinant of A. Remember, from this first step, we are going to now compute the determinant of A. Which A they are talking about here? And they are talking about this A. They are talking about this A. So we are going to compute it by the determinant. So remember, to find the determinant of 2 by 2 matrix, it is always multiplied by the corresponding. So from the given example, let me just take the A out from the given example. So A is going to be 5 minus 3 minus 2, and then we have 4. There we have 4. Let me use another color. And then we have 4. So this is the A matrix from the given example. And this other aspect is the explanation aspect. So here now, remember to find the determinant of 2 by 2 matrix, we multiply the corresponding. So this is going to be now, to find the determinant of A and I going to be, is the same as this. And this is just the real aspects to see how it goes. So it's going to be 5 multiplied by 4 minus into minus 3 multiplied by minus 2. So 5 times 4, this is 20 minus 3 times minus 3, this is 6. So the determinant now is 20 minus 6, this is 14. So the determinant of A is going to be 14. So this is exactly what they are explaining there. These other aspects. So this is the reality aspect of it. So we move again to the third step. The third step is saying that we are to formulate the matrix of AX and also formulate the matrix of AY. How do we formulate this? To solve for X and Y, we create a new matrix. We are going to create a new matrix. That's the underlining word there, the key underlining word there. By replacing, by what? Replacing, let me take this highlight. By what? Replacing, we are going to replace what? The representative column of the A matrix with the matrix B, with this matrix B, that is the constant. So now, let's take again from the real example. From the real example, remember, after we have we have find the determinant, the third step is saying we have to formulate matrix for A, X, and A, Y. From the original question now, this was the A matrix. We have 5 minus 3 minus 2, and then we have 4. So from this, they are saying we are now going to form another new matrix that is called AX. But how do we form AX now? Remember, from the original question, we can notice that we have this 5x minus 3y. We can notice that this aspect here is the x column. You see the x column. So we are going to replace this x column, the coefficient of this x column, with the constant. That's what this third step is saying. to form a new matrix that is called AX. So meaning where we see 5 and 2 is going to be replaced by the constant D matrix, which are 28 and 14. So 28 and 14 is going to be replaced with what? 5 and 6. Because this 5 and 6 is on the X column of the original linear equation. So this is going to be now 28 and 14. And then what is remaining here is minus 3 and then 4. So this is what we do for X. And also for Y, again, we do the same thing again for AY. Remember this time, this other aspect is for Y column. Because from the original linear equation, we have 3y and then we have minus 3y, we have 4y. So this, we are going to replace it also. So this is how we are going to put it now. So AY now is going to be, this now is going to stay 5 minus 2, and then it's supposed to be minus 3 and 4, but no, we are going to replace it now with the constant. With the constant matrix that we call B. So this is going to be 28 and then 14. So this 28 and 14. So we have replaced it. So this is the third step that we should formulate matrix AY and AX. That is to form a new matrix. Now, the fourth step is we are going to compute this new matrix now by finding the determinant of AX and AY. Remember, we have gotten AX to be 28, 14 minus 3, 4. So AX to be now 28, 14 minus 3 and 4. This is AX. So they are saying from this new matrix that we have formed now, we are now going to find again the determinant for AX, not A, but AX. So in finding the determinant for AX, this is going to be that. Remember again, it's always like that. We multiply the corresponding. So it's going to be 28 times 4 minus into minus 3 times 14. Yeah. So if we go, this is going to be 28 times 4 28 times 4, which is 112 minus 3 times 14 is going to give us into minus 42. Remember, minus times minus, it is plus. So this is going to be 112 plus 42. So this is going to give you 154. So 154 is the determinant AX. So meaning AX is equals to 154. So this is for AX. Just follow this step. You are going to solve any given matrix. So let's go again for AY. Let me use other color. So remember, AY is now from the previous, after we have formed the new matrix. So what is the matrix now for AY? It is 5 minus 2, 5 minus 2, and then we have 28, then we have 14. So this again, we find again the determinant. So it's going to be AY determinant is going to be now, we multiply again, 5 by 14 minus into minus 28, 28, this is 28 times minus 2. So this is going to be 5 times 14 is 70 minus into 28 times 20, and it's 56 minus 56. And minus times minus is plus, so 70 plus 56. So you need plus 70 plus 56, it is 126. 126. So the determinant for AY is 126. So this is the determinant for AY, 126. And this is at the explanation. I'm just giving you a clue or a clear example to see how this explanation goes. So we move again to the final step now. That is, we are going to solve for X and Y using the Cramer's rule. We are now going to solve for X and Y using what? The Cramer's rule. So the Cramer's rule is saying that for you to determine X, it is always the determinant of AX divided by the original determinant. And for you to determine Y, it is again the determinant of AY divided by the original determinant. So this is the formula. So now let's take again from the example. Let's proceed. What do we have for, what is the determinant for AX? Remember, this is lyric. This is what we have for AX. And this is also what we have for AY. So let's just consider first AX. So the determinant now for AX, the determinant for AX, remember, it is this one, 154. 154. So this is the determinant for AX. And the original determinant now, remember the original determinant, it is the determinant we have for A matrix. That is this one, 14. The determinants we have for A matrix, that is the A matrix is the coefficient of the variable which we have taken as. That's the A matrix. So this is the determinant of A. That is from the original or from the A matrix which we do not replace to find AX and another AY. So it's 14. So we have it to be 14. So the determinant of A is equals to 14. So that's the mode. So we divide. So this is going to be now 14 and 154 divided by 14. 154 divided by 14 is 11. So let me put it again. This is 154 divided by 14. This will give you 11. So we have got X to be 11. And then also for Y, it's the same thing again. We take for Y again the same thing. AY determinant, we have it to be 126. So this is equals to that. Determinant of AY is equals to 126. And then the original determinant, that determinant for A, it is again 14. Remember, this is 14. So this is now going to be 126 divided by 14. What do we have? 126 divided by 14. We have 9. So meaning we have got X to be, therefore, X is equals to 11 and Y is equals to 9. So let me place this again. So this is it. So X is 11 and Y is 9. So this is how you solve simultaneous equation using the Cramer's rule. This is very simple. It's us, and I'm Kalawa. In the next video, we are going to discuss on the inverse method.